Hi everyone, welcome back. So let's talk about text embeddings, right? So how can we generate text embeddings using AI's API? How can we store them in a vector DB and how we retrieve them? So that's the main agenda of this tutorial. So this will be quite interesting because most of the RAG concepts are based on this. So without any further delay, let's get started. Okay, so when you go to docs.edenai.co and search for the embeddings, you'll be seeing this page. Or even if you go to AI APIs from the application, and then when you search for text embeddings, so you'll be redirected to this docs page, right? A couple of things we need to understand here. And there are a lot of params we have for this API. So we'll address them step by step. And since it's not a specific tutorial on body params, so I'm not going much in detail about this. So it's already self-explanatory. So I'll just give you a high-level view of how the body params work and what are the main body params we have to use in this case. And you can feel free to explore this. You can try it out here. So let's start. So the first things first, settings. I mean, it's straightforward. It's basically it's to specify the models, right? So it's basically a JSON object. You can see here, say this example. So Google is a provider, and uh, so that's an example Google model. You can take something like Gecko or something. And providers are basically the providers. For example, Amazon is a provider. OpenAI is a provider. Provider has multiple models, right? So with providers, you can select one provider, then followed by providers. Let's say sometimes the providers may fail, right, due to some, I don't know, ingestion issues, or the timeout issues. I don't know, some sort of issues that may happen, and the providers may fail. So it's always ideal to have a fallback provider. It's like a plan B. So when the provider A fails, the provider B comes into the play. So basically, you can select up to 5 fallback providers, and it goes into the order, right? The first one is the second, then the third. So yeah, again, it's self-explanatory. And yeah, response is a basically the default option is true. The response it's basically the object of responses, right? So you can expect something like this. But when it's set to false, it's basically a list of objects. I mean, it's up to you. It's how you're gonna engineer afterwards. So you can change it. So not a big deal. Attributes as list. It's also the same thing. You expect each attribute and the value of each attribute in a list. Then you may have to set it to true because the default is false. So yeah, and the most important parameter we need is texts. Right, this is the input. So this is what is going to get transformed into embeddings. So these are the params we have here. And if you see the available more providers we have, there are a lot. There are a lot. Like OpenAI is the provider, the models, text embeddings, text embedding 3 large, small. Cohere is one of the providers we have, Mistral, you know. And so let's say if you didn't specify any model as such, so we have some default models available already. So for example, OpenAI takes ADA002 as its own default model. Google's Gecko, right? So so these are pretty much about how the body params work here. And let's understand how this you can use this in our API as well. But before that, let's try something out. So if you can see, there's a small code snippet available on your right side, right? So it already has this API, the embeddings API, and the payload is already mentioned before. The payload has all the body params as we mentioned before, right? Along with the headers. So fun fact: if you can add, okay, we can use this to play uh, on this page. So the provider, okay, we can try OpenAI slash. So OpenAI is the provider slash the model. Okay, let's go here to the available providers. Let me select this text embedding 3 small. I want to try this. It's very popular. So, okay. So you can see here it's getting updated. It's fascinating. And then fallback providers, we can have, I don't know, probably some Google slash. Let me go here. Hmm, Let me select Gecko. Okay. It's not state of art, but works for this case. And let's leave everything and let's go to the main part, the text. Yeah, let's try. I like uh, taking whey protein. Yeah, I go to gym, so I like taking whey protein. And then, so you can see there's something called texts getting updated, right? Okay, and everything's done. Make sure you have updated this as well. If you don't know where it is, it's pretty straightforward. You have to open the Eden AI app, and then you may have to go to the APIs section, and then you will find your own dedicated API. So there's a complete separate tutorial for on this available, like how to create APIs, how can you monitor APIs and all. Make sure you check that out as well. So we take that API key and then we paste it here. And then if I hit try it, couple of seconds, and then we get this response, right? Yeah, so it's a huge embedding, of course, right? These are the vectors, vector representation. So these are nothing but semantics, right? So the idea of why we are using embeddings is to understand the semantics of a sentence, so that even if you rephrase a sentence, you can relate it to the prior one. So it's quite fascinating, and embeddings are essential for any AI activity, text or image, even image based, right? Okay, so we got the cost as well, how much cost incurred here, and the total tokens, everything success. So everything's fine. We got the embeddings and everything's fine. So how can we implement this in our project, right? We have this API, we have this code snippet. How can we use this code snippet into our project? And then how can we store this embedding? We got the embeddings, so we need to store it somewhere, right? Let's say for text, we store it in a DB relational, or something like a MySQL, SQL, Postgres, or something. But since these are embeddings, these are vectors, we need to store it in a vector DB. How can we store them? And how can we retrieve them, right? That's the main thing. So let's see how I'm going to do this. It'll be quite simple, so you don't need to worry. Let's get started. Okay, so this is the code that I have written. It's a small fast API based project, just to let you guys understand how this embeddings API work, right? Let me just give you a brief of how I wrote the code and what are the parts of this code has. Okay, so kind of imported everything, Then this is where you give your API key, hidden AI's API key, and then I've added all the cores middleware. But if you are using it for the production grade, you may have to modify this a bit. So please don't forget that. And then yes, I have defined the pydantic models, right? And then yeah, so till then everything is like straightforward standard. Here comes the part where we need to focus. So there are lots of vector DBs available. So before that, why do we need a vector DB? We need to store vectors. We need to store embedding somewhere, right? So we need a vector DB. We cannot use a general conventional vector, so conventional DB like Postgres or something, right? So there are lots of vector DBs available, like Superbase, Pinecone, VV8, etc. etc. But for now, for this tutorial, I wanted to use Fast by Facebook. It's very light, it's very simple, and it's very fast. For this demo, I think this is good enough, right? So it has a dimension of 1536. Yeah, so I've created a few methods here, like load or create index method. We create the indices we require, right? And then we have to save the index, so there's a method for that as well. And one method to store the embeddings. How can we store the embeddings? We basically we take the embeddings we which from the Eden AI's API, so we get the embeddings, but we convert them into the NumPy array. The idea behind this is pretty straightforward. We may have to use it for many other purposes, like for example, we may have to use it for some data processing tasks using pandas or matplotlibs for plotting. So NumPy is very efficient, right? So we cannot use direct embeddings like that. So we need to convert it to the NumPy array. And there are other reasons as well. So we convert it to the NumPy array and then we reshape it and then we add it to the index, right? And then we store it to the metadata and then, yeah, that's it. We save the index. So this is standard. This is how any DB, vector DB thing follows. So it's standard. We follow the standard. And then there's another method to search, right? We have the DB set up and we have all the records present in it, like the vector-based vectors present in it. But we need an algorithm or we need something to search the records, right? So this method is for that. So it's again the same. The idea is let's say we have three, for now, we have three sentences. So converted into vectors and we stored it to the vector DB. Let's say I have a query. I got a query. So that's a new sentence. And I want to search related, um, you know, sentences or words from the vector DB to the query I have. How can we do that, right? So we have to convert the new query which I have into the embeddings again, and then embeddings to the NumPy array again. And then we kind of match this particular array to the list of arrays we already have in the DB, and then we kind of cross-check it, and see, okay, this query is more related to the first record we have. So the first record is the one which I expect, something like that. So okay, so we convert the query to the NumPy array, so straightforward, and then I'm checking if the index is empty or not, right? And then we also have to provide like how many results do we need? Is it only the one or top two or top three or top n, right? So this method is basically, sorry, this is a kind of condition to see, if it is not exceeding the index value. Straightforward condition. And then this is the part where we are searching the indices. So FAS has already a method, .index.search method, that searches all the queries along with respect to its records there. And then we finally format it and we return the results. That's it. That's straightforward. Okay. And then we initialize the vector DB. Okay. And now I wrote a logic to get the embeddings, right? But this is not mine. Of course, I snatched it from the Eden AIs. That's what I was telling you. If you remember, we had a code snippet available, right? So we can use that code snippet directly into a project. That's what I've done. So you can see this complete code snippet is available on Eden AI's docs. And then, yeah, I used it. I mean, I modified it a bit for my project use case. And yeah, so this is where the routes come into play, right? So I created a post endpoint. It's /embedding. So this is where we generate embeddings. So this local endpoint calls the Eden AI API, and it generates embeddings for that. Okay. Okay, this is pretty simple again. And then one more endpoint to search. So we generated endpoints and then we stored it into the vector DB. Everything is done. How can we search it, right? So with this particular endpoint, we can search. So it's basically calling the fastdb's dot search method again in this method. That's it. So that's pretty much it. That's how I created a simple embeddings related project. Now let's see it in action, like how it works, right? Okay. Okay. So if you remember, this is the endpoint that I have. It's running locally, right? And this is the body uh, of my. Uh, this is the body of my API. So it has a text. And this is one sentence. Metadata is basically the source or category. It's up to you. You can select. You can change it if you want. Um, and the text, again, the second text, the third text. So I have like three texts, basically three sentences. I want to store it in a DB. Okay. So if I hit send, what's happening? Okay. Okay. I think it's done. So yeah, you can see the embeddings got already generated a lot. A lot. Okay. Good. So now, if I go to okay, so the embeddings are generated and now stored it into the DB. So the idea is to search, right? I mean, that's what we need to see. So if I type something like this, where dense vector representation of data is possible, that's the question. So ideally speaking, it should return this, right? I mean, that's because it's very close. I mean, we can interpret it with our own eyes. So and I choose OpenAI as my provider and text embedding small and top K2. It's basically the two results that we expect. And if I hit send, okay, makes sense. So dense vector representation of data is possible. Yes, it is possible, and the score is 55%. So yeah, I mean that's how you basically search in the vector DB. So if you have thousands of data, tons of vector data, uh, still this is the same procedure, right? And this is how the comparison works. Basically we use the cosine similarity score. That's how the uh, retriever is working here. I mean, there are a lot of other scores available, but cosine similarity is considered to be one of the best metrics, or you can say the scores, to retrieve the relevant files because it understands the semantics and you know, even if you rephrase a sentence, even if you modify the sentence but the meaning is same, it almost try to get the exact relevant sentence from the vector DB. So yeah, I hope you have understood the concepts very clearly. If you do, thank you so much. If you get any doubts or if you have any issues, please don't forget to go to the Discord channel we have at the help section. You can post your queries there, and there are also docs available on the Eden AI's platform. So feel free to reach out. So thanks again. I'll see you.